Hello, welcome to a video where we are trying to create a linear model. So our scenario is described to us in words. At the top of our screen, it says a 1,000 milliliter IV bag is infusing at a 2-keep open rate of 40 milliliters per hour. The IV was started at 0800 hours, and we're to complete the chart with the amount of milliliters remaining in the bag. So when the bag was hung at 0800 hours, it would have had its full volume of 1,000 milliliters. Now the bag, we are told, is running at 40 milliliters per hour. So my understanding is that from 8 to 9, 40 milliliters would have been infused into the patient. So the milliliters remaining in the bag would drop by 40, and so I would have 960 milliliters remaining in the bag at that point. The same thing happens from 9 o'clock to 10 o'clock. So again, 40 milliliters are infused into the patient and therefore removed from the bag. And so by 10 o'clock, the fluid level in the bag is down to 920 milliliters. You can do the math on this. We continue to subtract 40 milliliters each time, and we fill out the rest of the chart, which would give us the milliliters remaining in the bag at each of the times listed. Then we move on to our first bullet point, which says write a linear model for the situation. So a linear model is going to follow the formula y equals mx plus b. In that formula, we know that m is the rate of change or slope. And we know that b is the starting amount. So when I look either at my data set or at the words that describe the scenario, I see that the IV bag started with 1,000 milliliters. So that is my start or my B value. And I see that each time, each hour, the change was 40 milliliters. And specifically, it went down by 40 milliliters each hour. Now, when we're dealing with time as our x variable, it actually could be misleading to use the slope formula. Let me show you. So our slope formula says y2 minus y1 over x2 minus x1. So if I subtract, I have 960 minus 1,000. And looking at my times, I have 0900 minus 0800. So subtracting the y values on the top gives me negative 40, which we have as our slope. But subtracting the times gives me 100. And if I see this as the number 100, I will get a wrong answer. I have to see this as time, and I have to see this as 1 hour. So that is why I truly just reasoned this through, that it is changing by dropping 40 milliliters per hour. And I feel like that is the better way as opposed to using a formal slope formula. So combining what we have reasoned out, we would fill in y equals negative 40x plus 1,000. So this is saying that my IV bag started with 1,000 milliliters, and each hour the fluid level dropped by 40 milliliters. Now it asks us to use our model to calculate the amount of fluid remaining in the bag at 8 hours. And here, looking at my chart can be very helpful. I see that the time is the x variable, so I would like to put the 8 hours into the formula for x. So y equals negative 40 times 8 plus 1,000. And so I'll just go to my calculator to do that. So negative 40 times 8 plus 1,000 gives me an answer of 680. And so we would expect that if we had counted out 8 hours and did all the subtractions the whole way down, we'd end up at 680 when we were 8 hours into the IV. Next, it says use your model to calculate the time. So this is important, calculate the time since the IV was started, giving that the nurse noted 600 remain in the bag. Again, based on my data, the 600 is a milliliter amount, and that is definitely, the milliliters are Y values. So this is a Y value. So I'm going to go up here where I have a little space and put the 600 into my formula for a Y value. So 600 equals negative 40x plus 1000. I have a little bit of algebra to do to solve this. So my first step of algebra is to undo the addition, and I undo that by subtracting. So I will subtract 1000 from both sides of my equation. And so these cancel on the right-hand side, and I just have negative 40x. I have to do the math on the left-hand side, and I get negative 400. Now my second step of algebra is to divide by negative 40. Again, on the right-hand side, things cancel, so I just get x equals. On the left, I do that math on my calculator, and I get 10 hours. And so 10 hours into this IV, the fluid level would be down to 600 milliliters. In this example, we met our objectives for our lesson this week, which are to write the model. So we did that right here. And then to use the model. And so we use the model in two different ways. And we use the model to predict milliliters, and we use the model to predict time.